let's start because we do have a homework, right, that was due Monday, but I pushed it back to due tonight. So that's that homework there, right? Okay, and then this one is not due until Monday. So I don't think, and I've added some new assignments, but the immediate thing that's due is this one. But we still have to finish our activities from last time, so I don't think we'll get a chance today to work on that homework. So that'll be up to you to finish that before midnight tonight, right? Okay, after class. So, but many of you have, a lot of you have already worked on that, started that, because I looked at that before class. So I don't think it's many of you that have to finish that. All right. So. Well, start that. Some of you may have to finish it, but not many of you have left to start that one. So wrap that one up right before midnight, right? So you can maintain your really good homework score. Okay. Taylor's passing back your goals. So most of you wrote a very nice goals, very specific. Okay. Just a couple of you wrote things that were a little bit vague. But remember, we want to think about just specific things that you're going to do between now and test 2, right? To raise your score on test number 2, right? Something not aspirational, like I want to earn a 4-point GPA, right? Okay, but more specific. I'm going to review my test, right, and correct my my answers on test number 1, or I am going to work on the sample test more diligently right before test number 2, or I'm going to visit the math center to get help, right? Okay, things like that people wrote down, okay, and those are good. Those are the so if you didn't write something specific like that, be thinking about a specific goal that you're going to implement before test number 2. But of course, what you write there is not going to help you unless you actually do it, right? Okay, so I actually want you to do those things, okay, that are on that card, all right? That's how you will raise your test number 2 score. So don't be in the boat of having the same regrets right after test number 2 that you did after test number 1, if you had a low score. But many of you had very good scores, so it's just a matter of continuing, right, the things that you're doing, okay, to continue to be successful. Do y'all have any particular questions that you want to ask at the moment? Okay. Things that from that homework or anything that you want to talk about. Remember now, the test answers are posted, right? Okay, so they're posted on the Blackboard page. But again, I want you to correct your tests without looking at the test answers first, right? So try to go through it and correct those things that you missed the best you can from reviewing your notes or reviewing your homeworks, right? Okay, or reviewing the sample test before you look at the test answers, okay? Because that's what you get the most benefit. Now, if you just look at the test and look at your grade and put it away, then that's not going to be really a learning experience for you, okay? Well, the thing you might learn is you weren't prepared for test number 1, right? Okay, but we want you to absorb some of that content, right? Okay, so that you'll have that for test number 2, and then ultimately, right, for the final exam, we do have a comprehensive final exam. Here's what happens in college. C students just look at when they get tests back, they just look at their grades, okay? Well, C and below, they just look at their grades, and then they put the test away, okay? B students will look at the test, okay, and look over the test and, look at the questions that they missed, right, okay? But it's A students that go back and correct the test, right? This is true, all right? So this is not a myth. I'm telling you, right? This is the behavior of A students versus B students versus C students. And you really want to get yourself into that A category, right? I hope you want to get yourself into that A category So take the time to correct the test, all right? It probably only be half the test or less, right? Okay, there's only a few of you that scored, less than 50 on the test. So you only have half the test to review. It's not that daunting a task. Okay, for many of you, it may be a lot less than that, a smaller percentage than that, right? Okay, so it won't take too long to do that if you haven't already done it. Okay. I don't mean to nag at you or preach at you, but those things are important in college, okay? You'll learn those lessons eventually, but better to absorb them early, okay, before you end up with a GPA that you don't want in your first semester. And it's hard to raise GPA, okay? Not easy to raise a GPA, all right? So you got to keep that high, because once it gets low, it's hard to bring that back up. Okay. All right, so we're going to go ahead and launch into the notes there then. And and then hopefully get through quite a bit here before we get to our continuing our class activity. We had to finish that one from last time. We got the back page still to do. You may have done it already, but we still need to talk about the back page. So I hope you brought that with you, class activity 3. If you weren't here last time, I've got a copy. Taylor will give you that later if you need a copy. And but I've got a companion activity for this. So we have a class activity 4 also. You can save that one later on. That goes with 3 once we finish the one I gave last time. Okay, let's do just a little fast warm-up here, a reminder of linear functions, okay? So I have a question here for you. A popular black market method for money lending, okay? So this is not regulated money lending. This is just, it's not really black market, but it's kind of just person-to-person money lending. A popular method for doing that is the 5-6 method. Have you all heard of this method before when you're borrowing money? Okay, all right. All right. So, so the way believe me, this is used widely. Okay, in many places. All right. The way this works is for every $5 you borrow, 6 must be repaid. Okay, and the usual limit for a loan like that would be a month, all right? So the terms of the loan there would be a month, all right? So here's my question. Using this method, is the cost of the loan, not the loan amount itself, but the amount you pay to borrow the money, okay, right? Okay, so sort of like the interest, right? Is the cost of the loan a linear function of the loan amount, okay? So a cost of the loan, for instance, for a $5 loan, right? Okay, since you have to repay $6, the cost of the loan is $1, right? Okay, not $6, but $1. Okay, because what you paid for the loan is $1, right? Okay, is the cost of the loan a linear function of the loan amount? Okay, right? So is the cost a linear function of the loan amount? How can you decide that? Okay, so think about that. Talk about that with whoever's with you, right? So we have to have it's going to be a yes/no answer here, but we need some sort of explanation for why that would be the case. Okay, so is the cost the amount you're going to pay for the loan, not the amount you're repaying, but the amount you pay for the loan, is that a linear function of the cost amount, okay? So what question do you need to answer there to decide if that's a linear function or not? I guess you'd even have to decide if it's a function, but I'll give you that. Okay, all right. The cost is a function of the loan amount, all right. But is it a linear function? Slightly different question. So yes or no, and you just have to have a you have to give me some sort of reason. So with your group there, right, or whoever's next to you, come up with an answer. We'll stop at 11:45 there, so I'll give you 2 minutes more. So the answer is just yes, no, and why, right? Okay. You don't have to really give me some elaborate answer here. Okay, so we're out of time there. Oh, yeah, okay. How many people there, so let's have a show of hands. We'll pull the class there. How many people say yes, they think it is a linear function? So raise your hand here, okay. So that's quite a few there. How many think no, they're not a linear function? You have to commit. It's got to be either yes or no, right? So let's try this again. Nobody voted no, so let's raise your hand if you think it's a linear function. I got to have a hand up. Amber, what are you doing? Okay, so, well, all right, so that's great, but, all right, are you voting yes there, all right, for is this a linear function or not? Okay, all right, so that seems pretty unanimous there, all right. Most people are voting for a linear function, so let's discuss why, if you think it's a linear function there, why you voted that way, okay. So what reasoning there did you put behind that? Nadine, why would you say that's a linear function? What's constant there?
The difference is going to be constant.
Okay, so I think let me change your terminology there a little bit. Okay, I think you're using constant like steady. All right, and it's good to use the term steady rather than constant, because constant function means something quite specific. All right, okay, so when you're saying constant there, I think I know what you mean. All right, but in math, constant function, since that has a specific meaning, I think in this situation we might steer away from that terminology. All right, so let's say steady. So what is steady there in the problem? Okay, so let's explore what you said there. All right, so I'm going to make up here, because we're a math class, right? Okay, and so this is always going to be my instinct. Let's make up some variables here to represent the quantities in the problem. All right, so what's supposed to be what I ask you here is the cost of the loan a linear function of the loan amount? So let's let y be cost
of the loan, right? Okay, because that's supposed to be the output here in this scenario, right? And then I'm going to let x be the loan amount, all right? And let's just explore some. Let's just explore some outputs that match particular inputs. All right. So I already gave you, Nadine, that that y is going to be a function of x. All right. Okay. So that was sort of implied, but I mentioned that, right? Okay. That the cost is indeed a function of the loan amount. So and that's pretty easy to understand, right? If you know the loan amount, you'll be able to figure out what the cost is going to be, correct? Okay. You're certainly not going to mistake that if you're the one borrowing the money, right? Okay. Because if the moneylender comes back and asks you for more than you're supposed to repay, Nadine, you'll immediately say what? You'll tell them you're charging me too much, correct? Okay, right. So I don't think you would have any problem figuring out, right, determining how much you're supposed to repay, right, for this loan. Okay, so indeed, see, the cost is a function of the loan amount, right? You can figure out from the loan amount how much you're supposed to repay, correct? Okay, not. And actually, that 5/6 is kind of gives you a method, right, a rule of figuring that out, right? Okay, so that 5/6 method is kind of a function rule, okay, right? And that's what allows people to figure out what they're supposed to, how much they're supposed to repay, okay. All right, so so let's write down some. Repayment amounts here. So if you borrow 5, right? Okay, right? Then what is the cost of the loan going to be? Not how much you repay, but what's the cost of the loan they're going to be, Nadine? $1. That's right. Okay, $1. So let's up this a little bit, and we'll make it easier on ourselves here. So if we up the loan to 10, okay, then how much are we going to have to repay? 2, right, okay. Or if we up the loan to 15, of course you can borrow different amounts, but just to make these calculations easier, let's say if we borrow 15, how much are we going to have to repay here? 3, right, sure, all right, and so on and so forth, correct? So we know how to calculate that. We know how to calculate that function, right? Okay, from the description of the way the money lending works, right? That's why people use this method, by the way. Okay, is because everyone can understand it, right? It's easy to understand. Oh, I know how much I have to repay, right? Okay, using this method. Okay, not complicated. Now, but look, Nate. So definitely the cost is a function of the loan amount, right? We just calculated those outputs, right? So we do have a function here. But now, Nadine, how do you determine if it's a linear function? So that's where the steady becomes really important, right? Okay. So what's steady here?
What did you call it? The cost of the loan is steady.
Well, it's not steady. It is changing,
I mean,
right?
it's like increasing, but at a, like, that's why I said constant, like at a constant rate.
At a steady rate, right. Yeah, it's increasing at a, yeah, I'm just trying to, constant is synonymous there, but I'm trying to steer you away from saying constant, right? Yeah, so, yeah, the loan amount is increasing at a steady rate, okay? Now, see, the way we say that formally is, right, okay, and this is how we've been talking about linear functions. When we increase the input by a steady amount, right, the output is changing by a steady amount, right? Okay, so see here, when we increase the input by 5, the output is changing always by what? 1, right. Okay, the output is always changing by 1. So see, that is indeed a linear function. That's what makes this this situation linear. So the function f here that I wrote down, right? Okay, that is a linear function. So the answer here is indefinitely yes. Okay. All right. So I don't know why everyone answered yes, but I hope it was for these reasons, okay? You may not have thought about it that clearly or been able to explain it that clearly, all right? But if you have some idea related to the fact, right, that that cost is increasing at a steady rate, right? Okay, then your intuition about linear functions is, well, you have at least some intuition there about linear functions. Now, let's make it a little bit tougher. Can we write down the formula for this function? All right. So see, when this function is described, right, in practice, when the actual money lenders, the people who lend money, where this method is used, okay, of course, when they describe this to the customer, they describe it the way I described it, right? Okay, but can we write this function down as a formula, right? So we know it's a linear function. Can we write down the formula for this? Can we write down the formula for this linear function? So so I want to write down a formula for f of x, but I've already figured out, right? I've already figured out that f of x is a linear function. So that gives me a really important clue here to write down this formula. If I didn't know that f was a linear function, I would really be kind of at sea here. I'd really be kind of in the dark about what to write down for this formula. But I know that f is a linear function, right? Okay, so that tells me, Juliana, that this function is going to look like what? So what's its format going to be? What's that format for linear functions?
Like mx plus.
That's like, yeah, it's not like that. It is that, right? Okay, so you got that right. Mx plus b, that's right. Okay, so we know that this formula is going to be mx plus b, and all we have to do is fill in what's the m and what's the b, but we know what the m and the b are supposed to be, correct? Okay, not their values yet, right? But we know sort of their what their practical significance is. What's the b? The y-intercept, right? So the y-intercept for this function, I don't have a graph of this function, but can I deduce what the y-intercept is here without the graph? Remember, the y-intercept is the output that matches what input? 0, right. So Kevin's memorized that now, so you guys need to memorize that also. The y-intercept is always the output that matches the input 0, okay? The output that matches the input 0. That is going to end up as where the graph crosses the x-axis, because at the x-axis, the x is 0, right? The input is 0. Okay, so geometrically, the y-intercept is where the graph crosses the x-axis. But in terms of the formula, it's the output that matches the input 0. So what would be for this formula? It's kind of strange to talk about this, but what would be the output that matches the input 0? See, it's kind of strange here to talk about an input of 0, because that means the loan amount is 0. Of course, if the loan amount is 0, right, then none of this really applies, okay? But let's still think about it, okay? What would the cost be for a loan amount of 0? 0, right, sure, right, okay. If you're not borrowing any money, right, you're certainly not gonna incur any cost, correct, right, okay. So the y-intercept here is 0. Oh, so we know what goes in for b there, right, okay. So that's really useful. We're halfway now through the formula. We have m times x plus 0. Nice, easy y-intercept there, right? I guess you don't even need to write that down, because it's 0. So your formula just simplifies to m times x. Now, so that was easy to figure out. The other part, not quite as easy, but pretty easy. What is m? No, what is it? We'll talk about its value, but what does it mean? It's the slope, right, okay? So m is the slope here. Now, so m is the slope, right? Now, the basic definition of the slope is that is the increase in the output, right? Or the change in the output, I should say. It may not be an increase. That's the change in the output when the input x increases by exactly 1. Unfortunately, that's not completely obvious, right, what that is in this problem, because in my examples here, I have the input increasing by 5. Right? So the slope here is not 1. You may be thinking, oh, the y is changing by 1, right, when the x increases by 5. That's not the slope, okay, right? The slope is the change in y when x increases by exactly 1, right, okay? So how can we figure that out since it's not just immediately obvious from the problem? That's where that slope formula comes handy, right? Okay, so we talked about the slope formula last time in the notes. We wrote it down in lots of ways. Don't worry, we're going to revisit it today. But one version of the slope formula is you can calculate the slope as the change in y divided by the change in x. And in this formula, the change in x does not have to be 1, okay? The change in x can be anything. That says change in x if you can't read that. And then you just find what the corresponding change in y is for this change in x. Take the quotient, and that will give you the slope. So in our example, we always have x changing by what? 5, right, okay. And when x changes by 5, what's the corresponding change in y? 1. So the slope there turns out to be 1/5, okay? That's how much y would change when x increases by 1. That's kind of obvious, right? If y goes up by 1 when x increases by 5, then that means y goes up by 1/5, right, when x increases by 1. Oh, so there's your slope. So now you can fill it into the formula, and you're done. You get a very simple function rule here for the cost, right? Okay, just 1/5 times x. There are many linear functions like this in practice where the y-intercept is 0, okay? We're going to see several examples like that, okay, where the y-intercept is 0. Those occur so frequently they have a special name. That's called a direct proportion function, all right? A direct proportion function, linear function where the y-intercept is 0, okay? Those occur, as I mentioned, lots. Here's an example of one. They occur a lot in science, okay? Frequently in science applications will involve linear functions where the y-intercept is 0. And but in your science class, they'll call these direct proportion functions. That's what they are, okay? Linear functions where the y-intercept is 0. All right, so there, oh, look, we can write down the formula for that function, all right, for that linear function. That's one thing that we want to do with linear functions is be able to write down their formulas given some information. We also want to be able to graph them too, okay? That's pretty easy as well, as we practiced last time a little bit. Let's look at this question, though. So it's pretty obvious because of where I've located the question that the answer here is going to be no. Let's explore why that's the case, all right? So now, if you don't repay the loan, okay, the loan's going to have to be refinanced at the end of the month, right? Okay, so the principal is going to roll over for another month, okay? And unfortunately, after a month, if you do not repay the loan, let's say you don't pay anything on the loan, though, so let's look at the worst possible case, all right? So we borrow $5, we don't repay anything. So at the end of the month, okay, now that's very hard to do with black market lenders, all right? So if you don't repay the loan with black market lenders, then they'll make things unpleasant for you, okay? But in any event, okay, so if you don't repay the loan, all right, you have to roll over the loan amount into the loan plus the cost. So for the second month, you will have a principal of $6 that you're paying, that you have to pay for, right? Okay, so notice that after 1 month, you're no longer paying for the $5, you're paying for the $5 plus the $1 you were supposed to repay at the end of the month, right? So in the second month, you're paying for $6, all right? See, okay, and then in the third month, you'd be, if you didn't repay anything, you'd be paying for even more. So here's my question. Is the cost of the loan then, if we don't repay anything, is the cost of the loan going to be a linear function of the length of the loan, all right, in months, okay? So if we just borrow money and then don't repay it, we keep having to roll over the principal, right, for another month, then will the cost we pay for that loan, will that be a linear function of the length of the loan? Let's just experiment with this a little bit, okay, and see what happens, all right? So let's imagine, so notice here, I don't have in the problem here the loan amount, okay? I just have the cost of the loan and the length of the loan in months, right? But I didn't give you, in this problem, there's no mention of the amount of the loan, so let's just make up an arbitrary amount. What's an easy amount to borrow? $10? Okay, so let's just imagine that we're borrowing $10, all right? And then let's compute what the cost would be for a given length, right? So I'm going to call the cost again y, right? Okay, and then let's call here the length of the loan now. Let's call that x, all right? So the question is y a linear function of x? Y is definitely a function of x, all right? But let's see if it's a linear function of x. So let's see. If we wait, if we repay the loan in 1 month, right, then what's our cost? We computed this a moment ago, right? So remember, the amount of the loan, we're assuming that's $10 just for the purpose of this, of this computation. So what did you say there, Kevin? Did someone say something? 2? Okay. Yeah, that's right. Right. Okay. We borrowed $10, so the amount we're going to have to repay is, after 1 month, right, would be 2, correct? Okay. All right. Now, but here's where it gets trickier. So what are we going to have to pay after 2 months? All right. So if we didn't repay the loan, right, okay, how much do we have to repay after, or what's the cost after 2 months? Not how much do we have to repay. We always have to repay the $10, right, okay? But what's the cost then after 2 months? Can y'all calculate that? What's that going to be?
Wait, you're asking total cost or like just the...
Not the amount you repay, okay, but the cost. So you're going to have to repay the $10, right? Okay, so that's always included in your repayment. But the cost would be the amount above the $10 that you have to repay, right? Okay, that's what I mean by the cost of the loan. So if you wait 2 months to repay, what is your cost? If you only wait 1 month, you pay $2, right? Okay, is that right? Okay.
So this is after 2 months, included with the 1 month.
Mm-hmm.
So 6.
Okay, so let's break this up into parts, right? Okay, so you're saying, okay, look, after 2 months, I'm definitely gonna I owe the $2, right? Okay, right. So that's part of my. That's definitely part of my. That's definitely part of my cost, right? Okay, right. But what else now is in that? What else now is in that cost? See, you have, you have the second month, right? Okay. How much do you owe, though, on the second month?
Wait, does that include the cost of the first month as well?
It certainly does, okay? Because here's what's going to happen. At the end of the first month, the money lender is going to come back to you and say, you owe me $12, right? Okay. You owe me $12, right? The $10 plus the 2. Okay. You say, I don't have it. And the money lender says, okay, that's fine. I'm going to refinance the loan for you. But how much is the money lender loaning you in the second month? Not 10. No. How much is the money? You didn't repay anything. So how much are you borrowing in the second month?
Including
Including the, yeah, that's right, okay. So what are you really borrowing in the second month? $12, right, okay. The the original 10, right? Ah, because you owe 2, right, okay. Yeah, okay. I am going to add in the second month, right, okay. Oh, all right, so let's not add in the, okay, all right. Well, all right, so let's not think about this then. How much do you then repay there in the second month? How much is the cost of borrowing $12 for a month? How much is the cost of borrowing $12 for a month? Borrowing $10 for a month is $2, correct? Right, okay. But in the second month, you're not borrowing $10 anymore, right? You're borrowing 12 because you didn't repay the 2 that you owe, right? So you're borrowing 12. What's the cost of borrowing $12 for a month? We just wrote a formula down for that, I think, right? Okay. Yeah, it's 2.4. How did you get that? Wasn't that just 1/5 times 12, right? Okay. Which was how much, did you say there? Ah, there you go, right. Okay. So now your cost there is 2.4, right? Okay. What about third month here? What now? Oh, yeah, so how much are we borrowing in the third month then? Well, what was your cost there?
Is it 14?
Yeah, it's 1440, right? Okay. Because remember, say at the end of 2 months you don't repay anything, correct? Right? Okay. So how much now how much now have you borrowed?
Would that be like 18? Because like $1 for like each 3 months, 3 plus 15, 18.
Okay, so after 2 months there, right, you owe the 10 plus the
So we owe $12 in the second month, and in the third month we add another 2, so that's $14.
14.4, right, yeah, okay, right. So I should have added in the 2, okay. Your cost is the $2 plus this amount, right, okay, which adds up to 440. So in the third month, you're in the hole for what? 1440, right, okay. So now you're in the hole for 1440. So how much do you have to repay? There's this amount, right? The 440 plus, what's the new amount that adds on to this? Well, it's 1/5 of that, right? 1/5 of this total. Can y'all figure that? So add those two numbers to what? 7.28? Okay, right? Ooh, boy, all right. Our costs are really adding up, right? The loan is getting quite expensive now. But but we have enough now information to answer our question, right? Okay? Because look, as x increases by 1 here, right, is the output, is the total cost always going up by the same amount, right? First it went up by what? 2 to 440 was 240, right? But then from 440 to 728 was, yeah, what's that difference? Yeah, from 440 to 728 is what difference there? Yeah, it's 2 something, right? Okay. 288? Okay, right. No. I think it's 268, isn't that right? So this is 240, right? This difference now is 268, you see, okay? So, right. So it's not a linear function, right, okay? This situation does not describe a linear function. The total cost is not a linear function of the length of the loan, right, okay? Actually, your cost there is increasing, correct, as time goes by, okay? It is 288, you're right. Okay. But still not a linear function, right? Okay. Right, yes. Okay. It's not going to be a linear function, right? So you don't have a linear function when the again, if your x increases by a steady amount, but your y, your output, does not change by a steady amount, then you do not have a linear function. Okay. Yes, if you have a constant function, that is a particular type of linear function, and that has a horizontal line as a graph, okay? A constant function is a linear function where the slope is 0. Remember, I told you if the y-intercept is 0, that's called a direct proportion function. If the slope is 0, that's called a constant function. We'll see some more examples of that, okay? All right, let's, well, okay, that example took longer than I thought, but that's an informative example. It's good to be confusing, though, right? Okay. That's how we learn. All right. Okay, so let's take some examples that are a little bit more straightforward. All right. I've drawn some lines here. Okay. So here we have graphs, not a story told to us. Okay. And what we want to try to do is write down the formula for these lines, okay? So we've got the lines in graphical form. Let's see if we can write down. Their formulas, okay? So we're just going to practice exactly what we did in that previous example, okay? In that money lending example, the part that was a linear function, right? To write down the formulas for these lines, we know the formula is going to have what form, Juliana? Say it again for me. Y equals mx plus b, that's right. And we just have to fill in what is the m, right? Okay, and what is the b. So for all three of these parts, a, b, and c, okay, we're going to write down a formula that looks like this, because these are all straight lines, okay? Let's start with the easy one here, a, okay, because, Kevin, we just talked about this, okay? This is a horizontal line, all right? That's called a constant function. Okay, and it's going to turn out that for this function, the slope is going to be what? What did I just say? 0, right, okay. So since we already know the slope is 0 here, then for A, we can fill that in, and we get a very simple formula, just y equals 0 times x plus b, and b is always what? B is always the y-intercept. But here, I think we can just see the y-intercept, I think, okay? What does it look like the y-intercept there is? I think that's 2.5. That was supposed to be 2.5, okay? So we can just read off the y-intercept. Oh, no, is that, oh, yeah, that's right, okay? So the y-intercept is 2.5, so we just get this simple formula. Nadine, that's called the constant function, all right? So, and the reason that's called the constant function is notice that the formula there is just that constant value 2.5, okay? So that's why we call it constant. But the slope there is 0. So what's happening is when x increases in this function, this horizontal line function, when x increases by a steady amount, y is also changing by a steady amount. It's changing by 0 all the time, okay? Whenever you increase the x, the y does not change. It's always constant at 2.5. So that's why the slope is 0, okay? Now, you can also determine the slope from using the slope formula, change in y over change in x, right? But for this horizontal line, the change in y will always be 0, right? Because y is not changing at all, no matter what the change in x is. So you end up computing your slope as 0 divided by some number. That's going to be 0, right? Okay. So for constant functions, easy to see, or at least deduce, right, that the slope is 0 for horizontal lines. Easy to deduce that the slope is 0, and that's why you end up with this very simple formula. Okay, let's take one that's not so simple here. So let's look at B, right, this line that's going uphill from left to right. So this line is increasing from left to right. So we know something about the slope. We know the slope is going to end up being, I don't know what the number is, but I know the slope is going to end up being what? What sign? Positive, right. Lines that are increasing from left to right, they have to have positive slope. So again, I'm trying to write down the formula for this line. I know it's going to look like this, and I know the slope value here is going to end up as plus. But, you know, just knowing it's positive, greater than 0, that's not enough, right? I need to know exactly what that value m is to write down the formula. That's supposed to say greater than. But the b, I think I can figure out. Can I figure out the b? Tricky there, huh? Right? Okay. Because what's the b supposed to be? Yeah, that's supposed to be the y-intercept, right? Okay. And that, I wish I could see that on the graph, but it looks like the y-intercept is going to be what? Somewhere way down here, correct? Phooey, okay? So I was hoping I could read that off of the graph and see what that y-intercept is, okay? But unfortunately, I haven't drawn that graph big enough to find the y-intercept. Wow, okay, so, well, let's figure out what we're going to have to do about this. So let's go backwards there. I can't fill in the b, but let's try computing the m, all right? So we're going to use our formula, right, our slope formula to try to calculate the m, right, okay? And I've got lots of different variations of this slope formula, you know, change in y divided by change in x, right? That is sometimes shortened to rise over run. Right, we talked about why that's called rise over run last time, change in y divided by change in x. Here's the third version of the slope formula, and this is the one that we end up usually using in practice, okay, most of the time, okay. These other versions are useful too, though. What this formula uses are 2 points on the line. So if you know 2 points on the graph of the line, then you can use that formula to compute the slope. And what that formula says is just take the difference in the y-coordinates between the 2 points, take the difference in the x-coordinates between the 2 points, then just take the quotient, and that will be the slope, okay? Well, look, for this line B, it's been drawn in kind of a friendly manner because I know 2 points on the line. I don't know what the y-intercept is. That's somewhere way down here, okay? But I do have 2 other points on the line. I know this point 4, 4 is on the line, and I also know this point. That, by the way, is called the x-intercept. That's where the graph crosses the x-axis. And that's 3, 0, okay? So I can use those 2 points in my slope formula to calculate the slope. So at least I can get the slope, and then we'll figure out what we're going to do with the y-intercept here in just a second. So what are we going to do with the 2 points there, right? You calculate the difference in the y-coordinates between the 2 points. So let me do 4 minus 0. One of the y-coordinates is 4 and the other one is 0. You could have also done 0 minus 4, by the way. All right, so you could do it in that order as well. But whatever order you do the subtraction in the top, make sure you use the same order in the bottom when you take the difference in the x-coordinates. So I'm going to write the bottom here as 4 minus 3, right? Okay. And, oh, that works out nicely. As 4 over 1, which is 4. So the slope here is 4. I guess I could have seen that from the graph also. Notice, because these 2 points are on the graph, what this is telling you is if you increase x by 1 from 3 to 4, notice that's an increase of x by 1, right? What does y change by? 4, right, okay? But remember, that's what the slope is, right? It's the change in y when x increases by 1. So just because of the 2 points that I was given here, I also could have figured out that the slope was 4, okay? When x increased by 1, y increased by 4. But we also got it from the formula, so we get 4. Oh, so let's fill that into our mx plus b. So I have so I know half of this now. I know y is equal to 4x plus b. But this still leaves me with that pesky issue of what is the b, okay? What's the y-intercept? Because I cannot see that on the graph, okay? All right, here's where we're going to play a little algebra trick, though, all right? Look, this line that formula is supposed to match this line, right? That means that these points on the line have to satisfy that formula. So that tells me that if I plug 4 in for x in this formula, what does the y have to turn out to be? Got to turn out to be 4, because if it doesn't, the formula is not going to match this line.
So you solve for b.
You solve for b, that's right. Or you could also use this point. Plug 3 in for x, and that means that the y has to turn out to be 0. Otherwise, that point would not correspond to that formula. So we're just going to plug one of those 2 points into the formula, my partial formula here, and then figure out what the b is. Solve for b, okay? So let's do that. Let's use 4, 4 since I mentioned that first. So if I plug 4 in for y and also 4 in for x, this equation has to be true. So we get 4 is equal to 16 plus b, and now it's easy to solve for b. Just subtract 16 from both sides. So you get what? B is equal to what? Minus 12, right? So that's what the y-intercept has to be. Somewhere way down here where that crosses the y-axis, that's going to be minus 12, okay? There's the whole formula then. Y is equal to 4x minus 12. Oh, cool, right? See, we can write down the formula for that line B. So we got A. That was easy because that was a horizontal line, okay? Let me throw in, just before we do C, which will be the very similar process. So I haven't mentioned vertical lines. Vertical lines are lines, but they're not functions, okay? So that's why I haven't been talking about vertical lines. Why is a vertical line not a function?
It has more than the input thing.
Yeah, it has what now? More than one what?
Input for each output. Right?
Yeah, you're saying it backwards, right? More than one output for an input, correct? Actually, the input minus 3 here, the way I've drawn this vertical line, right? See, the input minus 3 has lots of different matching outputs, right? So that makes it not a function. So vertical lines are lines, but they're of less interest to us because they're not functions. But they're easy to write down formulas for vertical lines. They look like the formula for horizontal line, except you switch the x and the y. So the formula for this line is x equals minus 3, okay? Not y equals, but x equals. And in this case, x is going to be equal minus 3, because see, everywhere on this line, every point on this line has the same x coordinate, minus 3, okay? So see, that formula is also a constant, right? The formula here is a constant, but you can't call that a constant function because it's not a function, right? Okay, now let's look at, so keep in mind, vertical lines have formulas like horizontal lines, except you get x equal to a number rather than y equal to a number. All right, let's look at C. All right, so let's see if we can write down its formula really quick, right? Okay, so we know that's a line. It's a little bit wavy line, but that's a line. So, again, as always, right, we know the formula looks like this, and we just have to fill in the slope, right, and the y-intercept. Here, the y-intercept, though, is easy to fill in, because I can see that, right? What's the y-intercept here? 2. So we don't have to do any special work there to fill in the y-intercept there. I can see that that's 2. So that's nice. All I have to now do is calculate the slope is. But perfect, we've got the slope formula, right, to help us calculate the slope. And we know 2 points on this line. So should be easy to calculate the slope. I've got these 2 points, 2 and minus 3, and same x-intercept as line B, 3 and 0. So take the difference in the y-coordinates between the 2 points. It doesn't matter which order you use. So I'm going to do 0 minus 3, just for fun there. So 0 minus 3, difference in the y-coordinates, and then divide that by the difference in the x-coordinates, but make sure you take that difference in the same order. So I'm going to do 3 minus 2. Notice you get 2 minus signs there. 3 minus 2. So I end up with minus 3 over what, 5? No, that's it, okay? It's plus 5 in the bottom, right? 3 minus a minus 2 is 3 plus 2, which is positive 5. So we get negative 3/5. There's the slope. That's less than 0, but that's what it should be. It should be less than 0, right? Because this line is decreasing from left to right. Lines that are decreasing from left to right have negative slope. Lines that are increasing from left to right have positive slope, and flat lines have slope 0, okay? They're neither increasing nor decreasing, okay? All right, let's try that. Let's quickly repeat that process of finding the formula for a line. But I'm not going to draw a picture of the line, okay? So you can just imagine what the line looks like. It's easy to visualize lines because they're so simple, right? So we know here that this line passes through these 2 points. So you can imagine just mentally what that line looks like, right? Okay, so we really don't have to draw a picture of that. The curve is so simple. But I want to write down it. I'm not trying to graph it. I just want to write down its formula. All right? So we know the formula is going to look like this, and I've just got to fill in the 2 parts of the formula. So let's start with the slope, because that's maybe the more straightforward thing. You're just going to use the slope formula, right, to calculate the slope. And you can do that if you know 2 points on the line, but we do because We're given 2 points. So let's take the difference in the y coordinates. Be careful with the signs. So this is 3 minus a minus 8, or you could have done minus 8 minus 3. It doesn't matter. But then take the difference in the bottom between the x coordinates in the same order. So I'll have to write in the bottom 6 minus a minus 5. So you get lots of minuses there, but double minuses cancel each other, right? So we have 3 plus 8 over 6 plus 5. So that's 11 over 11. Wow, how nice. A nice slope, right? Okay. So this line has slope 1, which is a positive number. So when we graph this, this line is going to be going uphill from left to right because its slope is positive. All right, so let's fill that into the formula. So we know y is equal to 1 times x, or just x, plus the y-intercept. But now I have to figure out what the y-intercept is, and I have no idea what the y-intercept is, right, because I don't have a graph of the line shown to me here, right? But we don't have to have the graph, right? We can do this algebraically, because this line, remember, has to contain these points. And so that means that if you plug the coordinates into your partial formula, the formula has to be true. So let's take one of the 2 points. Let's try this one because it's got positive numbers, right? So let's take this point and plug the x and y values into our partial formula. And then we're just going to solve for b. So let's see, I get there what? 3 is equal to 1 times 6 plus b. So it looks like b is 3 minus 6, right? Or negative 3. There, you're done. So there is your, it turns out to be a really nice, easy formula, right? Y equals x minus 3. There's the formula for that particular line, okay? All right, so do y'all think y'all can follow that process for writing down the formula for a line, okay? What you really need, either explicitly given to you or sort of told to you, right, okay? It may kind of be hidden in the problem, but you need to be given 2 points on the line. If you know 2 points on the line, then you'll be able to write down the formula for that line, okay, by going through these steps, computing the slope, substituting one of the points in, and then deducing what by solving the equation, deducing what the y-intercept has to be, okay? We're going to use that process a lot. All right, but I'm going to show you next time, but we're out of time today, a little bit of a shortcut in this process, okay? A little bit of a shortcut in this process. We'll start the class with that next time. Okay, let's stop there, all right? And so we'll take about 5 minutes break, and then we're going to go back. We're going to come back, and I want you to finish the second page of the activity from last time, right? Okay, and then we have a companion activity that goes with that. Okay, so Taylor will give you another page, all right, for this, and we want to try to see if we can get that done by the end of the class.